hello to everyone again. Today we're going to, as Christian said, talk about data modeling. It's an interesting topic. Very much pitch this at, as the description says, a Cassandra 101 level. If you feel that there's something deeper you'd like to ask, please ask in the WebEx chat session or via Twitter, and we'll try to get deeper into things for you. Brief overview of what we're going to do today. We'll look at some general guidelines for data modeling in Cassandra. We'll talk about the APIs a little bit, the different ones and why there are different ones. And then we'll go through a worked example of how we could model an application. And we'll do the traditional Twitter clone. Yeah, that's what we do in the NoSQL world. So to start with some general guidelines, Cassandra is good at reading data from a row, stored in the order that it's stored. We can handle rows in the millions and the tens of millions of columns, or cells as they're now called for internal storage engine rows, and we can pull data out of those pretty quickly and get that back to you. It's even better if you can uniquely identify the row in the cluster, and we'll look at that as we're looking at the example. If you can tell us exactly, if you can give us a hint that lets us know which machines have that row, we can get to that a lot faster. Now, implicit in saying what we're good at, we should also say what we're not good at. And what we're not good at and we don't actually support are doing things like joins, doing aggregate functions of sum and min and max, applying an arbitrary order to things. And these are some of the things that you might be used to if you're coming from a relational SQL world, where you can pretty much do whatever you want inside that very powerful SQL language. SQL language doesn't try to be as powerful as SQL, and we'll see that in terms of the sorts of functionality that it supports. So to leverage the things that Cassandra is good at, we should typically build data models that denormalize data and use the order of the columns or the cells as they're stored inside of Cassandra. This denormalization is often seen as a problem, it's often seen as a wrong step, but it really does help in terms of performance. And in a distributed database, it's almost, I would say, necessary, because we really doing joins across multiple machines is a performance killer, and it also runs into a lot of issues around availability and partition tolerance. So if we're going to denormalize to support the sorts of queries that we want, we have to understand what the application is going to do. We have to understand, for example, in our Twitter example, we'll see how we've listed out the queries. We want to be able to get back this entity by this ID and store the data appropriately to match that. So let's look at the different sorts of APIs we have. The fact that we have multiple APIs is, let's say, not ideal, but Cassandra started out a long time ago with this very simple thrift RPC API. It was there. Thrift, for those that don't know, is a piece of technology that came from Facebook. It's probably why Cassandra was using it. And the RPC API with Thrift had some initial advantages. It allowed us to define the interface in a language-independent interface definition language, click a button, and it would auto-generate code in almost any language that we wanted. That was great, but then on top of that, though, there seemed to be a lot of work to make a language-specific client. Things like Picasa for Python and Hector for Java and all the other ones had to do a lot of effort to make it idiomatic and make it match what they were expecting. There are also some issues around stability with Thrift, and upgrading was painful for the client libraries. And also there started to be some concerns that a strict RPC interface perhaps wasn't the most expressive way to deal with things. So starting in version 0.8, I believe, from memory, CQL was created. The CQL stands for Cassandra Query Language. It's an SQL-like language, and it was created as a higher-level declarative alternative that would be more stable over time because it wasn't binary-based and as interface definition-based like the Thrift RPC. We've had a couple of versions of CQL now. We're up to CQL 3. CQL 1 and started in version 0.8 of Cassandra. CQL 2 was in version 1.1. And CQL 3 has a lot of changes, and it's considered to be in beta in version 1.1. But it has a bunch of things that are backwards incompatible. So it's really a break from the way that CQL 2 did things to the way that CQL 3 did things. And we're considering this to be beta. In version 1.2, I believe the intention is to take the beta wrapper off it. But there is still an open opportunity for people to play with CQL 3 and see if there are any edge cases that for their particular workloads that it doesn't suit. I said CQL 3 was different. It really is different. It uses a table-orientated, schema-driven data model, and that's quite a difference to the column family model that we've used in the past. The best way, I think, to get into it is to go through an example, and I think that's what we'll do next. So this Twitter clone example that I'm working on, that I'm going to step through here, I've done this previously at a talk here in New Zealand called WDCNZ. There's a video of this talk available, and if you Google that title, you'll get to a slide deck on SlideShare, and the code that I talk about is also linked from there. And in the previous example, in my previous talk, I did it using Thrift and RPC, and specifically using the Picasa interface. So we'll be able to see, if you want to see how it's different, you can look up that old talk and see what happened there. To use CQL3, I'm using the CQL-SH command line tool. With you start it with -3, and that puts it into CQL3 mode. That's a property of a connection onto Cassandra, and at the moment in version 1.1, the current stable version, we default to using CQL2, and it's an upgrade on the connection, part of the connection string. So let's look at what we want our Twitter clone to do. We want to post a tweet, and we want to be able to read a tweet by its ID. We want to list all the tweets that a user has sent and list the tweets in a user's timeline, which would include the ones that the user has from the people the user follows. And we want to be able to list their followers, and so we understand who to deliver the tweets to. There's a bunch of other things that you would want this sort of thing to do. These are the basics, and so let's just deal with those for this presentation. Let's start down the data modeling path. We have this thing called a key space, which some of you may be familiar with. It hasn't changed. The key space is a namespace container, and it has a light bit of configuration with it. It's a very lightweight object in the Cassandra world. So go ahead and create our key space. So we have create key space command, and we specify a name. and we specify the network, the replication strategy. In this case, I'm using the network topology strategy, which tells Cassandra that we have one or more data centers that contain our nodes, and we may want to replicate our rows different numbers of times in different data centers. Now, this statement is working for Cassandra 1.1. The create key space statement has changed a bit in Cassandra 1.2. Specifically, the strategy class clause has changed. The online help for the CQL SH utility works very well, and it explains how to do create key space in 1.2 if you go and get that. So the next thing we want to do is create some tables. Now these are sort of the CQL3 version of what previously we called a column family. They're under the hood, they're still column families, but they look a bit different through CQL3. So we could say that a table in CQL3 is a sparse collection of well-known ordered columns. I say they're well-known because they're all defined in a create table statement. So the CQL3 and Cassandra know the columns that we expect. They're ordered in the sense that they're still ordered by their name, and they're sparse because Cassandra only stores, for each row, Cassandra stores the columns that the row actually has a value for, and it stores the name with them. And just the same way that the storage engine has always worked, we don't expect every row to have the same columns. So let's get to our first table. We have a user, like we would normally have in any sort of system, and initially we just have a username, a password, and a real name, and they're all text, which I believe means under the hood they are Unicode text, because everything should be Unicode nowadays. And we declare a primary key, which helps us identify these rows uniquely in the cluster. The primary key is analogous to our row key. So after creating that table, we can insert a user into it just by using the insert statement there, and read that user back, and we see we get it back in a very tabular form, and this is not really very exciting. We've just stored a couple of bits of data and read it back. So if we have another user who signs up who doesn't give his real name, this time we can see on the insert statement, we can just specify their username and their password, not bother with their real name. And when you read back Bob in the second lower half of that slide, select star from user, where username equals Bob, you can see CQLSH has shown null for the real name. Internally in Cassandra, we haven't stored the real name column, we've just stored that that row has a username and a password. CQLSH has decided to show it as a null. If you're using something like the Python DB2 API, you'll be seeing whatever Python is saying for a null, which might be a none. If you're using it through JDBC, you will see a null or whatever it is that is appropriate for that language. So our data model so far is pretty simplistic. We've just got a user. If I was going to put it into some sort of data model, in some sort of diagram, I might start with this. But I think for what we're going to talk about today, about how we've got some entities in our application, how we want to access them and model them, I'm going to build a table where on the left-hand column is a list of values, like username, and going across the right are the different column families, and we'll describe how those values are used in those column families, whether they're primary keys or just fields. So our next feature that we want to be able to do is store a tweet and get it back by a particular, by its tweet ID. So we have our tweet table. Very simple here. Tweet ID is a big integer, a body, a username, and a timestamp. Again, a primary key that allows us to uniquely identify this tweet in the cluster. You can insert into this guy very simply. Should note where for the timestamp column, I've used the Unix epoch time. You can use in CQLSH. You can use a formatted human time if you want to, and it will the CQLSH will reformat that appropriately. And then if we read that tweet back, you can see we've got one tweet with a body and a timestamp and the username. So if we look at our data model now, we've said that we've got a tweet ID, which is the primary key for the tweet table, and a username, which is just a field on the tweet table. We haven't done anything other than store it. I wouldn't call it a foreign key because you cannot read tweets by username from this table. You can only get a tweet if you know the tweet ID on this table. So next, what about if we do want to know about tweets in the context of a user? We'll create a table called user tweets. It has all the same fields as our tweet table, but this time the primary key is a combination of username and tweet ID. Under the covers in the storage engine, this creates one row where the row key, the key that will allow us to identify that row uniquely and efficiently in the cluster, is username, and the tweet ID is used as a prefix for the other columns. So CQL3 here will present us with one row for each user tweet. Under the covers, this may be this one row. Under the covers, multiple rows will be stored on one storage engine row. So we go ahead and insert into our user tweets column, user tweets table. Insert looks just the same as we had before, and we read it back, and we can say select from user tweets where username equals Fred. And again, very boring example, not that different to what we saw before. So I could also select where username equals Fred and there's a particular tweet ID, and in this case there's only one there, so again I'm not really doing a great job of examples. So let's put in another tweet. So if I add a second tweet now and we do select star from user tweets where username equals Fred, you can see I've returned the two tweets that we put into Fred's user tweets row, but their order doesn't really feel right to me. Their order should be reversed. So I can add on to that select clause, order by tweet ID descending. Now I get them back so that the second tweet is first in the row. And we haven't cheated here. The order of things inside Cassandra has been maintained. We've just reversed it. The tweets on the storage engine row are stored in ascending tweet ID, and we've just said we want them in descending tweet ID. We haven't said something like, well, now we want it sorted by the body of the tweet or the timestamp or anything like that. We're still using the order of things in the storage engine. We're just, instead of starting at the beginning, we're starting at the end and going backwards. The next table we would create would be a user timeline. So this would store tweets that I've sent as a user and tweets that I've received from users that I follow. Again, it's just the same as our user tweets table. So we won't do an example there, but we can now look at our data model and see how it's growing. we can see that we've added user tweets and user timeline, and in both of these, the username is still the primary key, and the tweet ID is a component of the primary key. So we're starting to get a feel that there are two entities in this application. There's the users and the tweets, and we're storing different data about them, or we're storing data about those entities in different ways, in different tables, still addressable by the natural key of the entity for the most part, and optimized to support the different types of read queries that our application wants to do. As well as storing individual tweets, we probably want to store some metrics about how many tweets a user has sent and their followers, how many followers they have and how many people they're following. Cassandra, since version 7, off the top of my head, has had the distributed counters. They're still available in CQL3, of course. It's just a data type called counter. So we can declare a table very simply like this. We can use an update statement with a set, which is very familiar to SQL. And we can just say, update the user metrics, set username equal to Fred, where set tweets equal to tweets plus 1, where username equals Fred. And we're updated that counter. We can increment it and decrement it, and we can increment it and decrement it by more than 1. And we can see in our select statement that we've got null back for followers and following because we haven't done anything to update them. Again, jumping back to how we're looking at our data model here, user metrics is something that we're storing about this entity, which is the user. We address the user by their username. And so username is the primary key on our user metrics. The last area that we'll look at today is the relationships between users. Now, tables are pretty easy to create in CQL3, and they really promote the idea of creating it. It's the way to go. In the past, we may have done this by having a situation where you might have one column family and do something tricky with your row keys or something like that. So now let's make it simple and say, let's just create two tables, one for followers, one for following. They're basically the same, except they've got a different field. One's got follower and one's got following. And we'll set the primary key to be the username and then the follower. There's a little bit of an abstraction leak here. There's a ticket which has been fixed in version 1.2, I believe, which would allow us not to have to put the timestamp column there. The timestamp column there is just to get around this problem in Cassandra in CQL3 running in Cassandra 1.1, which means that you have to have a table with at least one non-primary key field. Let's just ignore that for now, just pretend it doesn't exist. Really all we want here is a list of, for this user, who are their followers. So we can insert into those two tables. Let's say Bob starts following Fred, so we insert into the following table, one for him, and into the followers table we insert against the Fred row that Bob is one of his followers. We read that back, we see really no surprises there. The following field, which was used as part of the primary key, column is just a column. So it's come back in the row that we've got Bob and Fred, Fred and Bob, two different rows. It's really, I hope that these examples have been very boring because they're not really very surprising. If we look at our data model now, the followers and following column families, again, both use the username as a primary key field, as a primary key, and they also use it as part of as a primary key component. So that's been our brief overview of a data model using just CQL3. It's different to people who have perhaps been using Cassandra before. I think it has some advantages, definitely. It allows you to talk about your data model a lot easier. There are some performance improvements that come from the types of queries that CQL3 starts to construct. And so I hope you found that there's some interesting facts in there for you. Thanks, Christian.
Definitely helps if I take myself off of mute. So thank you very much, Aaron. This is the portion of the webinar that we open up to questions. So you can either ask questions directly in the WebEx Q&A panel down here, and I've seen a couple in here already, Aaron, that I'll ask you. Or you can, if you're on Twitter, you can ask questions via the hashtag CassandраQA, and we will try to get through as many questions as we can. In previous webinars, the Q&A portion has been very popular, so let's see how we do. So while we're waiting for people to ask some questions, a couple of housekeeping items. So we got some questions during the webinar that people were having trouble with the computer audio. So rest assured this webinar is archived and will be available online, and we will send out emails to everyone when that is available. Okay, first question, Aaron. Okay, here we go. Is a table in CQL like a column family?
Yes, they are. They are in column families plus, let's say that. One row in a table can be one row in, a table maps to a row maps to a column family. One row in a table in CQL3 can be stored on one storage engine row, one old column family row. But CQL3 will do what you might want to call a projection and store and present to you multiple rows that are all stored on one storage engine row. In the past, a lot of data models basically did this. They said, in the tweet example, you would say, okay, I might prefix my column names with the tweet ID and then the property of the tweet. So be 1 colon body, 1 colon username, 1 colon timestamp, and I'd store that on one row, and then also in that row I'd have 2 colon body, 2 colon timestamp, etc., etc. So you are kind of storing multiple things in the same storage engine row. CQL3 takes that abstraction and makes it more of a first-class entity. We saw when we had a primary key, if we have a compound primary key where the username is the first part and the tweet ID is the second part, you're creating a situation where multiple table rows map to one old-fashioned column family storage engine row. I hope that's answered the question.
Yes, thank you very much, Aaron. This one, could you please outline how to denormalize relational data models into Cassandra data models?
Okay, let's say you might have had something like you're running an e-com site, and you might have one relational database table for the order header, and one relational database table for each order item. And you might store those, so you've got you've normalized there so you're not repeating the order items in the order header. In Cassandra, you would go the opposite way. There's a thing in CQL3 which I haven't touched on today called sets or collections, and you could have your order represented in just one CQL3 table. There would be some fields at the top that represented things like your total, your ship date, the customer ID, and where you've got repeating entities, you could do that by using CQL3 sets and lists. That's one example there. Thanks.
Okay, great. Once I've denormalized data, any insert update requires addressing multiple tables. Is there any recommended idiom?
No, you will have to do those. And you have to insert into multiple locations. CQL3, like Thrift, has the idea of a batch in the API. This is not a transactional batch. It's just a batch designed to reduce network overhead. If you have a request that is making changes to the same row, all of those things are applied to the commit log as one. So they're either atomically committed or not to the commit log. All updates to the internal column family are also applied in an isolated way. So if you send an update for, say, 3 column families because you've denormalized your data, if they all have the same row key, if all those updates have the same row key, they'll be committed to the commit log as one unit. When they're applied to each column family, they'll be applied in an isolated fashion, so you won't get partial results being visible to readers. And then if your update fails for any reason, remember your writes are either potent with the exclusion of counters, and you can send it again.
Okay, thanks. Question from Celia Tong. How do you update if you never inserted a record to user metrics? I think that's going back to your Twitter example.
Yeah. So everything in Cassandra is, well, you could say everything in Cassandra is an update or an insert. Everything's an insert, everything that overwrites. But basically everything in Cassandra is an update. We don't have a concept of, so everything's an insert or an update. You could think either way on this one. We don't have a concept of going and modifying data in place. And this question gets down into some deep areas of how the Cassandra storage engine works. In a relational database, when you do an update, you're telling the database engine, oh, you've got to go and navigate the B tree that represents the table. Take some locks as you're going down this navigation. When you get there, I need you to go to this particular 8-byte column and change its value. And in Cassandra, when you write a value, we put that value into the commit log, just like a relational database. And then we store it in memory in this thing called a mem table with the appropriate timestamp for that request. When it comes time to read, we are looking to return to you the value with the highest timestamp in the context of what we didn't touch on there, but we call this consistency level, which has to do with how many nodes are involved in the request. So we don't have to go and update and change the old value. If you've written that foo equals bar on a Monday and that's on disk, and then on Tuesday you write foo equals baz, we don't go and change that foo equals bar on disk somewhere. When it comes time to do a read, we will, depending on how the read is structured, we might be able to know that the value you wrote on Tuesday, we find that first. If you said you just want to find out what value foo is, And we know that all the other stuff on disk is older, so we'll just return to you that foo equals baz, and we don't have to go and look at the old thing. So it has to do with how the storage engine works, and you can consider that everything is an update, and that and you're overriding values even if there is no value to begin with.
Okay, great. Questions coming thick and fast, so may need to keep your answers a little short. Paul Blazek asks, does each create table cause a new column family to be created?
Yes, they do.
I like the answer of that. Mark Malamut, this is more of a statement, but something to just consider. He says he'd be curious to see the data modeling extend to how indexing is laid out, column name, column value, etc. So
yeah, I think that might be a topic for a future webinar. We can do a more in-depth look at CQL3 once Cassandra 1.2 is out and we're able to use 1.2 as the examples.
Yes, Aaron, we were talking earlier, maybe that's a good additional topic, maybe sort of February timeframe, something like that. Okay, Tim Roper, for storing the time series data, is it better to use timestamps or time UUID for column names?
I would, if it was time series, I would use timestamps. I would use milliseconds since epoch. Depending on how frequent your data is, you might need some sort of tiebreaker in there as well. That makes it a lot easier for you to construct a query because the time UIDs, version 1 UIDs, have a part of those. The construction of those is the MAC address of the machine, and so it can be a little bit tricky to reconstruct them.
Okay, great. Trevor Harris asks, what can you do with secondary indexes? What are the limitations?
Good question. Secondary indexes allow you to, as the name implies, build an index on something that is not part of the row key. They are good for some situations where you have perhaps infrequent queries. They are not good for highly trafficked things that you expect and your application will have to do a lot. The main reason is that when you do a query that uses a secondary index, we don't know which nodes in the cluster actually have the results that you're looking for. So that query has to go to a lot of nodes in the cluster, every replication factor node in the cluster. Whereas if you do a query that can uniquely identify the row, we can direct that to the particular nodes that have that data.
Okay, great. And an additional question there. When are updates visible to other sessions? Is there a commit?
They are visible as soon as the update runs. So we don't have the idea of a database commit. As soon as the update has been committed into the mem table on the machine, it's visible. To which client it's visible depends on the consistency level that you are using. I believe we talked about consistency level in one of the earlier talks, which was an introduction to Apache Cassandra. We have an idea of the consistency level, which describes how many nodes are involved in the request. And the higher the consistency level, let's say the faster every node will see the results of a write, up to the point where all nodes are involved in reads and writes. And the lower the consistency level, the less likely it is that all nodes will see the results of a write.
Chris Hahn asks, do you have to declare a type for each column in create table? In the early documentation, it implies it wasn't required.
Yes, you do in CQL3.
Okay, Good, thank you. What are the restrictions, if any, on queries on a composite primary key?
I do not know all of the restrictions. I know that they work in the way that you expect, in the sense that you can read all the rows that have just the first part of the composite primary key. You can read rows which are then filtered by a query, but filtered by clauses against any any parts of the primary key that are not at the start. And I do not understand if there are any other further restrictions on querying against those. Sorry.
Okay, thank you. So from Zola Lin, I have a column family table which will be appended with the daily batch data for a source most of the time. The most current day's data will be retrieved. Should I make sure the daily data at one node or distributed across the nodes from the retrieval performance point of view? So I think the question is on a single node or distributed across all nodes for performance.
So your data will be replicated according to your replication settings for your key space. When you do a write, that data will be sent to the appropriate nodes. You often will replicate data first and foremost for reasons of availability, and I recommend that you use a replication factor of 3. If you are having issues if you're worried about performance, there might be other things that you could look at before you turn your replication factor up from 3, although it's certainly a valid idea to increase your replication factor, and then more nodes can be involved in a read.
Okay, thank you. I have a very specific question here from Gustavo Arjones. We'll see how you do with this one, Aaron. Do you have tips to model my PK using CQL? I have a social analytical tool and thinking about modeling such as source and then in parentheses Twitter, FB plus timestamp. Or should it be different to achieve balanced clusters?
I think that one of the concerns there is about creating very, very big rows. I may be wrong. That's definitely a concern. It's always been a concern in Cassandra. You don't want to create massive rows that are, I'm talking about things that are in the hundreds of megs, because they grow as they get processed by some of the maintenance procedures. They can take a long time. If you've got some sort of natural partition in your data, which normally is a date, normally you might partition, say, by month or by week or something like that, I'd recommend that you try to put that into your data model so that you know that rows are always going to be bounded in time in some fashion.
Okay, great. And Rodolfo Cohn asks, is the primary key for a table the row key in the column family?
Yes, it is. If you have a primary key that only has one component, it is directly analogous to the row key. Yeah.
Okay, great. Just going through here, making sure I've got them all. One more. Is there any non-aesthetic reason to separate out user and user metrics?
There is. Counters can only be used in tables that have counters. So you can't have a table that has a mixture of counter and non-counter columns which are not part of the primary key.
Okay, great. I think I've got everything. And we were, oh, we didn't do this one, I don't think. If you created a new key space, does everything you create after that go to new key space? Or do you need to specify which key space you create?
There's a use statement, analogous to most relational databases, and that just sets the context of what you're doing.
So, Aaron, thank you so much. Really appreciate your taking the time to present today and also to go through the Q&A. I know it's tough being having to field these questions that come thick and fast, so much appreciated. For everyone still on the line, thank you very much for attending. Please note that the next webinar, Creating Your First Node.js App with Apache Cassandra, we're actually going to move that date to November 29th at 11 a.m. Pacific time. And Russ Bradbury, another Apache Cassandra MVP, will be presenting, and it will be his first time presenting on this webinar series. So looking forward to it. Thanks again, Aaron.